Alright, this is the part 1 review to the 7th grade test. It is test 13. And like I said, we're going to split this up into 2 parts. So this is part 1. We're going to go 1 through 10 today. And just so we're aware, I want to remind us that each question that you see in this part of the review and the next part are very similar to, or those questions are very similar to what will be shown on the test. So we'll know what to expect. Alright, first one. What is the total cost of a car that is $10,000 with 8.5% sales tax? Alright, the first thing that we want to do is change our 8.5% into a decimal. It is a decimal as a percent, but remember we can change percents into decimal form as well. So we know that percents are out of 100. So 8.5 out of 100 is how we figure out the decimal there. So that will be, we could do 8.5 divided by 100, but what we should get for a decimal is 0.085. And a misconception is that here we would divide. But actually what we want to do is take this, the decimal form, and multiply it times our 10,000. And if we do that, we will get 0.00005. Add this. Looks like we get 850,000, but we actually don't. We have to count how many decimal spots back we have to go. So 1, 2, 3, 1, 2, 3. We're at $850. And what do we do with that? Well, we want the total cost, so we add 850 to 10,000, and we should get $10,850. Alright? That's how we do that problem. I will show you, coming up in a couple problems here, a few options to figure out percents. I went with that situation that time, but I will show you some different scenarios coming up. Alright, number 2. If you earn $60 at work and you work for 8 hours, how much did you earn per hour? So we want to take our overall pay and figure out what it is hourly, our unit pay basically. So we're going to take 60 and divide it by 8. And that should give us our hourly pay. So 8 goes into 67 times. 7 times 8 is 56. Do our subtraction. Yeah. 60 minus 56 is 4. And we drop our 0 down. 8 goes into 45 times evenly. So no remainder there. And we get 7.5, which is $7.50 per hour. So there we go. $7.50 per hour. Alright? That one should be fairly easy for us. Number 3. The ratio of boys to girls is 5 to 7. If there are 63 girls, how many boys are there? Well, for this we usually use a ratio table. Doesn't mean you have to do that, but that it helps us organize. So we got ratio, actual, boys, girls. And we fill in what we know. So boys to girls is 5 to 7. We know there are 63 girls. How many boys are there? That's what we're searching for. We can set up a proportion if we want to. 5 over 7 equals x over 63. We could cross multiply divide if we wanted to. sorry. So we could do 5 times 63 divided by 7, that would give us x. We could do it that way to figure out how many boys there are. We could also just look at our table here, and I know that we get from here to here, I know 7 times 9 is 63, so if I do 5 times 9, I should get our answer, and that would be 45. So 45 boys there. Alright, 5 times 9. Alright, now that is one version of the test, but there is another version. I'm giving 2 versions of this test, and one of the other versions gives a scenario more like this, where we take this out, and then we say the ratio of boys to girls is 5 to 7. If there are 120 students, then how many boys are there? Alright? Now this doesn't specify boys or girls, this is 120 students total. So what we have to do is add on a total row to our chart, and then we fill in from there. Boys to girls is still 5 to 7, but remember for total, we add up our column, so 5 plus 7 is 12. We know there are 120 actual total students, and we are searching for boys still. Alright, so we could set up our proportion again, 5 over 12, 5 over 12 equals x over 120. Could cross multiply, divide again if we wanted to. But we could see here that to get from 12 to 120, we multiply by 10. So if we multiply these by 10, we should get our answer. So 5 times 10 is 50, and 7 times 10 is 70, but this was the answer we would have been concerned with. And you can see if we added 50 and 70, we would get 120. Alright, so it works out. Alright, so that's a different scenario, but that is another version of the test. So we want to make sure we see both of those ways. And remember that if they ask us, or if they give us a total, we have to add a total row to our chart. Alright, number 4. What is the average of 1 1/3, 2 1/6, 3, and 1 1/2? Alright, average is the same thing as the mean, where we add up all of our numbers and divide by how many there are. So we're going to add 4 numbers and then divide by 4, we should get our average. So we're going to do 1 1/3 plus 2 1/6 plus 3 plus 1 1/2. Lots of different ways to do this too. Sorry. But I'm going to show you probably one of the more quick ways. We do need a common denominator here because we have fractions. And I say we use a denominator of 6, probably the easiest one to use. This one already is a 6, and then we've got 3 and 2 that do go into 6. So we need 1 and something over 6 plus 2 and 1/6 plus 3 plus 1 and something over 6. Alright? So we've got, to get from 3 to 6, we multiply by 2. So 1 times 2 is 2. And to get from 2 to 6, we multiply by 3. 2 times 3 is 6. 1 times 3 is 3. Alright. Now what we can do is add our numerators up. We can go, well, let's add the big numbers first. So 1 plus 2 is 3, plus 3 is 6, plus 1 is 7. So we're going to have 7 and something over 6. Remember, we only add the numerators, not the denominators. So we go 2 plus 1 is 3, plus 3 is 6. So 7 and 6/6. Well, 6 over 6 is 1, so really this is 8. 7 plus 1, or add a 1 to it. 7 and 6/6 is 1, or 8, sorry. And then we want the average, so we have to divide this by how many numbers there are. So we're going to divide 8 by 4, and we should get an average of 2 when we do that. So that's how we would handle that problem right there. this is the one where I can show you a few different ways to do a percent problem. Okay. First and foremost, we can always get the decimal form of that. That's 12 out of 100, which is 0.12, so 12 hundredths. Basically 12 hundredths reads the same as this because the 2 is in the hundredths place. So this means 12 hundredths, and that's where we get that decimal from. Same thing if you did 12 divided by 100. Okay? We can take that times 650. That will get us an answer. Another option is we could think of it as more of a ratio problem. Well, let's do it this way too. So 0.12 times 650, so that's 12 hundredths times 650. So you could also do it a fraction way. Times 650 over 1, just taking 650, turning it into a fraction. So you could do your multiplication this way. Or, like I said earlier, you could set this up as a ratio. 12 over 100. This is 12% as a fraction. So 100 is the total, because that's percents are out of 100, that's total. 650 is a total. And if we solve for x there, we would also get our percent. Okay? Or not our percent. What is 12% of 650? That would also give us this right here. So you can see that in each one, we are multiplying 12 by 650 and dividing by 100 in some way or another. This is already divided by 100, multiplied by 650. This is 12 times 650 divided by 100. This is 12 times 650 divided by 100. So each one should work, and if we go ahead and do any of them, we should get 78 for an answer. You can do whichever way you are most comfortable with. Alright, moving on to 6. Dave gave 1/8 of his 128 baseball cards to his friend. A, what percent of his cards did he give away? And B, how many did he give away? Alright, so he gave 1/8 away. We're going to use that to find our percent. 1/8. What is that as a percent? We have a few different ways to do that. We're essentially trying to figure out what is that out of 100. So if we do cross multiply divide, 1 times 100 is 100 divided by 8, that'll give us our answer. Or we can do 1 divided by 8 and multiply it by 100, doesn't matter. So let's just do 8 into 100, so 1. Bring that down, we get 20. We'll get 2 of those go in there. Add on 0, 2 times 8 is 16, subtract, we get 4. Bring that down again, 8 goes into 45 times evenly, so 12.5%, or 12.5%, okay? And how many did Dave have left? Well, he gave away 1/8, so that's one way we can think about it. So what is 1/8 of 128? 1/8 of 128 is 16. That's basically 128 divided by 8. And if he gave away 16, that means he has 112 left of his 128. Alright? A few different ways to do that problem too, so you don't have to do it exactly like I did, but that's one way to do it, and that'll get you the answer. Number 7, some scientific notation. These should go by pretty quick. First, write 0.00009 in scientific notation. Well, we check and see how far we move that over so that we get 9.0 times 10 to the something. So 1, 2, 3, 4, 5. -5, because if we were to convert this back into this, we would want to move our decimal to the left 5 spaces. Alright, and remember we always want this number, the first one, to be between 1 and 10. So that's why we want that in correct scientific notation. Letter B, we're going to go backwards. We're going to turn it into standard. We're going from scientific notation to standard. And this tells us we're going to move our decimal 4 spaces to the left. And we can do that because this is a power of 10. Alright, it's basically like timesing this by 1 over 10,000, if you really want to think about it that way. Anyway, we're going to move it 4 spots to the left. 1, 2, 3, 4. Our decimal is there. We'll erase, and that should be our solution right there. So there's number 7. Alright, check my time real quick here. Getting up there. Alright. Number 8. In this parallelogram, measure of angle A is 50 degrees. Find the measure of angle B. So if that's 50 degrees, parallelograms, you could either figure that this angle and this angle are the same, and that these two are the same, and that they all add up to 360. You could kind of think about it like that. Or you could remember that these two are supplementary, they add together to get 180. So if I do 180 and subtract 50, I get 130 degrees, and that's what B should be. That is a much faster way to do it. Alright, number 9. Compare 3.5 kilometers to 350 meters. Alright, we're going to see which one's bigger or if they're equal. So I'm going to convert 3.5 kilometers into meters. I know that there are 1,000 meters in 1 kilometer. So 3.5 kilometers equals how many meters? Well, 1,000, so we can move it 1, 2, 3 spots. Or if we're to multiply that times 1,000, okay? So we get 3,500 meters. And that is bigger than 350 meters, so that one's bigger right there. Alright, so that's how we think about that one. And number 10, which will be the last one for today. Divide 8 by 0.37. Write the answer rounded to the nearest 1,000. I'm going to use the calculator here just to save time. 8 divided by 0.37. We get 21.621, and it keeps going on like that. We need to round this to the nearest 1,000. So this is tenths, hundredths, thousandths. We're going to round this one and look at this one to tell us if we'll go up or down. This is 5 or bigger, so it'll be 21.622 when we round it up. Alright, that is the first half of our review. Look for the second part tomorrow. Thanks.